Hello and welcome to Behind Clean Lines, the podcast that you should listen to if you take safe food production seriously. Now, today we want to make things a little bit more tangible. We want to look into some of the design choices that you need to make if you want to produce or create equipment that goes into a safe food factory. Now, to educate us on this, today we are crossing the pond, and on a video link we have with us from Arkansas, US, Mr. Nate Harrison from Phoenix Innovations. And Phoenix Innovations, for those of you who don't know, specialize in equipment mainly for the poultry industry. So that be needle injectors, it can be filtration systems, heat exchangers, pumps, etc., all that kind of stuff. Now, Nate himself brings along about 20 plus years of experience in the poultry industry. So for today's episode, I think he is going to be just the perfect guest. Nate, welcome to the show.
Thank you, Mikkel. I appreciate you having me on.
Now, when you're building a food factory, we've talked about in the early episodes about zoning quite a bit. That's a big thing, obviously. So you have the low care zones, you have the high care zones where you really need to be careful. And I don't know, Nate, do you at Phoenix, do you vary the design between the different zones depending on what kind of zone it goes into?
We can. If it's going to be an area where it actually touches the food that's going to be moving through or touches the product that's going to be moving through the factory, yes, we will have a different design criteria. Sanitary versus something that doesn't have to be sanitary design. If something's going to go on the roof, like a heat exchanger or a rechiller, there's going to be different design criteria than one of our injectors or pumps that's actually going to be making food contact.
Yeah. That absolutely makes sense. Now, before turning on the mics, we said to ourselves, okay, we want to do 6 design choices that you've made at Phoenix, just for people out there to understand and to maybe think about if they are considering going into the high care zones. And we'll see if we can, if we have the time to go through all 6. But if we just start by the first one that you've identified, I just wrote down simple concepts. Now, can you try and, put a few more words on that? What do we mean by that?
Absolutely. So, in my opinion, and we've had Phoenix Innovations for over 5 years now operating, we've been making equipment, but I've been in the equipment industry as a total for almost 20 years now. But simple concepts basically means that I feel the industry in general has overcomplicated design. And what I mean by that is we've tried to put too many things in a small space, or we've put too many electrical components somewhere where mechanical components would do, or we've overcomplicated the control panels or anything like that. So when I say simple concepts, we really want to base that on 3 different things. Number one, the equipment needs to be safe for food production. The equipment needs to be accurate for its intended purpose. And 3, the equipment has to run day in and day out in some of the most demanding environments in the food business. If we think about those 3 things first, then we won't overcomplicate design. And when I say simple concepts, I mean making it easy to access, easy to clean, easy to maintenance. Those are the things when we talk about making things simple. We're not talking about making things cheaper or making things at a much lower cost because of something. We're talking about the best materials, but the simplest concept for operation so that we can continue to produce food safely at an efficient and accurate rate.
But now you mentioned cost, and I'm guessing that those 2 go hand in hand, right? So if you overcomplicate, you digitalize things that don't need digitalization, you put screens where they don't need to be or stuff like that. So you complicate your design in all kinds of ways. That will still also...
That's correct.
Yeah, that will be more expensive, right?
It does increase cost in certain aspects, but what it does is it increases cost to the consumer. And that's the problem, because you may not realize that cost up front when you're trying to sell that piece of equipment to the consumer, but they're sure going to realize it on the backside, whether it be in their aftermarket parts that they have to buy, the amount of service visits they have, the amount of time that they spend at one of my pieces of equipment tells me how well it's running. I don't want them to have to spend a lot of time at my equipment. I want it to run accurately and efficiently, and I don't want it to be a consistent problem or use a ton of parts or things like that. There's 2 distinct business models there. Taking cost into account on the front end of the project and taking cost into account on the back end. And in our industry, I feel like we have decided that the back end sometimes is easier to get money from our customers, consumers on. So we build things to use parts, or we build things with less care and design, and it ends up costing our customers more over the life of the product than it should.
Well, just real quick, why do you think it is like that? So people are not, I'm guessing people are not willing to invest in, I guess, high quality, simple builds that need little maintenance, but would rather have something a little, the capex would be a little less, but then the operational expenses will be maybe higher. Why do you think it is? Why do you think that's
the question really we need to be asking there is, why do we need all of these things? So don't get me wrong. We are capable of automation, networking. We're capable of logging in, doing online troubleshooting. Technologically, we're as advanced as anyone else. But the amount of motors that we're putting on things now, the amount of electrical fixes that we're putting in to try and prevent mechanical failures is causing issues in the marketplace. So that's something that we've tried to eliminate.
Now, moving on. You also mentioned stainless steel. Why is that something that we need to think about when we are making sanitary choices for our equipment?
High-grade sanitary steel is going to resist bacterial growth and be easier to clean. What we want to do is we want to use high-grade sanitary stainless steel designed appropriately with the correct slope, with the correct access platforms, different things like that, that prevent bacterial harborages. Advanced principles of food safety says, hey, don't give this stuff a place to grow, and it won't. Make it easy to clean, and you can prevent bacterial contamination. Less bacteria, less people sick. Less bugs, then less problems. That's where you're really focusing with your stainless steel.
But I can't but wonder, do you still see, OEMs out there producing for the food industry in something that is not high-grade stainless steel?
No, not very often. Not very often. Sometimes
Okay.
I'll see some things that I question, but that's not the way we design. So without critiquing their equipment entirely, no, but I do see some rust. I do see some things like that where potentially the supply chain issue post-COVID caused some of these issues because orders were high. People were just trying to get what they could get to produce for the industry. And so that set us back a little bit as well.
But are we back at normal?
I would say, based on my order quantities and the access of available materials, I am back to normal on our side.
Okay. Now you just mentioned slopes. That's also one of the points that we pinned out before turning on the mics. What do you mean by slopes, and why are they especially important?
Well, the slope of the way a piece of equipment is designed is important because it's going to prevent let's say water or some sort of product, whether that be brine, marination, or some sort of mixture in a plant, that's going to prevent it from sitting stagnant somewhere for an extended period of time. Stagnant means that bacterial growth could occur. So if you have the proper slopes and you don't have standing water, you don't have an area for bacteria to accumulate or soap to accumulate post-sanitation, things like that, then you're eliminating a pretty simple issue.
I can't but wonder, how would the client buying the equipment, I'm guessing that they should also kind of know something about, say, the slopes, but it could also be other kinds of things in the design in order to assess whether a design is good for hygienic purposes. How would they go about doing that?
Most of the time it's industry knowledge. Okay. It's going to be based on their inspection service or something like that. The United States Department of Agriculture occupies each one of our production facilities, and they have standards of sanitary design that have to be met. And the plants will often ask for, hey, do you have your statement of USDA quality of design or sanitary design features? And so that's something that we're going to provide with each piece of equipment, but especially if it's actually touching food product.
Yeah, because again, are we differentiating here between low care zones, high care zones, or is it something that you would just recommend all the machine builders to always think about?
It's more important in the high care zones. The low care zones, and like I said, that all depends. It depends on how the plant layout is set up. It depends on where they want to locate the equipment. But if it has product contact, if there's any product contact at all, then those things have to be carefully thought of and designed on the engineering side of your equipment.
Now, moving on to the next thing that we talked about there's one of those that seem rather obvious. It's easy cleaning access. Just in short, why is this something that you need to be aware of more than they already are?
Sure.
Because again, it's kind of trivial knowledge that it should be cleanable, but what do we mean?
So cleanable and accessible are two different things. We are pushing more and more product through our production facilities these days, and that's a great thing. What that means, and I'm mainly talking about the poultry side. So on the chicken side or the poultry side, it is still the most preferred protein. And in the United States, we're approaching 100 pounds per year per consumer of poultry. That's per person, 100 pounds per year. We're more than double the next protein segment that drops down below. So if you think about it from that aspect, we are asking these production facilities to increase because the population of America and the world is increasing. And being a global supply of protein from the United States elsewhere, from Europe elsewhere, from Australia elsewhere, we are asking these plants to produce more and more pounds to meet the demand of the people, of the growing population of the world. Now, that being said, we're putting more and more equipment into these plants without being able to make the plants bigger. Now, there are new plants being built. There are additions being made to these plants, but these lines are typically very tight. They're assembly line situations. And if your equipment is not accessible at the machine, and I don't mean give me a 20-foot block of wide open space around it. I mean, when you take the doors off the bottom of one of our machines to access the key mechanical features of the hydraulic or the air, if everything's jumbled and pushed into a very small space and it makes it difficult for a maintenance employee or a service employee to work on it, then you've created a problem for the plant. That could be more downtime. That could be more difficult to replace or insert parts. I mean, you need a piece of equipment that's going to run and that you can fix when it's time to fix it and that will run when it's time to run. If you don't make it accessible, people don't want to work on it. Oh, that machine's difficult. I can't even get under there. I can't get my hand in there. I have a hard time getting the pump out. Those are the things from a sanitary design facet. You've got to find space inside your individual footprint to give people the opportunity to appropriately develop solutions for problems and fix things when they're not working.
I think this is a perfect segue into bullet number 5 that we talked about, increased inspection points. I'm guessing that those two are fairly connected.
Well, an increased inspection points, again, is just having visible sight line of inspection as you're walking by. Because a lot of times a piece of equipment in a poultry plant doesn't have an individual employee assigned to that equipment that says, hey, you make sure this machine runs. Now, there may be a lead in that department that has 4 to 5 different machines they have to watch over, plus 30 or 40 people. That's a lot for one person to do. You want it when they have to come up and make a quick evaluation of a problem or whether or not it's running appropriately at that time or efficiently at that time. You want to give them increased inspection points. And what I mean by that is, what can they see with their eyes immediately when they walk up to that machine? Can they troubleshoot from a touch screen? Can they see that product is flowing the correct way through the machine? Can they see that it's draining properly? Can they see that the brine is actually flowing and being reused or recycled? Are the filters working properly? Those things that go into your sight line, that's what I mean by increased inspection points. When you walk up to my machine and you want to do a quick inspection on whether or not it's running efficiently, here's what I'm giving you. I'm giving you 6 areas to look at. They're very easy to read. They're very easy to access. And it'll give you a very good snapshot of whether or not your equipment is performing optimally.
And this way of designing for increased inspection point or easiness of inspection, is that customary in the industry?
It should be. The industry went that way, and then the industry fell away for a little bit, and then the industry came back. And basically, as regulation increases, inspection process increases. So what we've been able to do is, on our equipment, if you want to inspect something to make sure it's sanitary designed, we give you access to that, and we give you easy access to that. That may mean removing some bolts so you can look at the brine manifold chamber where we have absolutely no welding on the inside. It's fully machined so that there can be no cracks, no harborage points where bacteria could reside. It might be our drain system underneath our machine. Our machine all slopes one way. A lot of other machines slope to the middle of the machine. You have no visible inspection or sight line to where that drain is. If a piece of protein gets caught under there, it could be caught under there for hours before it's cleaned out and checked out. So we're looking at making it simple and easy to inspect, to design, to look at it from a sanitary perspective, and also look at it from an operational perspective and say, okay, this piece of equipment is doing what it's supposed to do safely and cleanly.
Yeah, yeah. It sounds like a lot, and we haven't even covered the last point yet. And I think just looking at the time a bit, but you mentioned tubing as well. I know this is maybe we might be jumping a little bit around here, but can you just put a few words on why is tubing important to look at when
so
you're
are you familiar with the term low-hanging fruit? Something that you can pick first. Yeah. Okay. So tubing is low-hanging fruit. Let's not do any tubing. Tubing is fully seamed, welded closed, but there's a pocket in the middle, right? If anything ever happens, if that weld cracks, if there's something hits that thing and crack, it can open up a small space where water and bacteria can continue to be harbored. Okay. We don't want that. We're going away from tubing in the industry as far as framework tubing is concerned. We still have to have sanitary tubing for product to travel through, for brine marination to travel through, but you can clean that sanitary tubing. There are CIP systems, which is called clean in place systems, that will clean that type of tubing. I'm more speaking about the framework of equipment. When you build a piece of equipment, you don't want to use any type of tubing in your framework. You don't want to use square tubing or round tubing, anywhere that water could be trapped and bacteria could begin to proliferate. You don't want that in your equipment. So that's just some of the low-hanging fruit. I still see people using tubing at times, and I think that's an old concept and it needs to go away. We don't use any tubing in our design of framework.
And what would you do instead?
So we use angle or we use channel. And so we use solid pieces of angle iron or we use bent plate channel. And so basically you have no interior pocketing. There's nowhere for water to accumulate or bacteria to harbor on that because it's designed so that there is no pockets. There is no area that you cannot see.
Great. I think now with these 6 real quick things that you should be looking at, what about if we just look a little bit into the future? What would you expect to be the next big thing in design choices for machine builders?
Well, I think we have to look at what the market's going to do. So labor comes and goes right now in the marketplace. Labor typically drives design changes on equipment. We either go towards a less labor-intensive model or towards a more labor-intensive model based on the cost of labor and the availability of labor. But what I see is automation is increasing all across the industry, and I'm all for automation. In our own processing facility where we manufacture our equipment, I use automation equipment. I use robotic welders. We use some AEV type stuff. We do different, which is automated electric vehicles. We do different things here to automate our process. That is which way this is going. So automation is a double-edged sword. It takes people off the line because it gives you a little bit more connectivity to that machine where you can see it from somewhere else. But at the same time, without people on the floor, sometimes you can't prevent problems as quickly. But I see the automation sector is not slowing down. Robotics, things that took people before because labor is expensive are going away. I see more and more. I see some really cool products out there that I think will have longevity in the marketplace. And I see some that come in with a bang and go out with a fizzle. And so what we're trying to do is combine automation on our equipment with practical, runtime oriented, simplistic design. So we don't want to over automate, but we're not going to ignore the future. We're not going to say, oh, we're not into that. We're old school. That's not true. Everything that we do is effective for now and effective for 10 years from now.
And now, what if you're just a really small newcomer in the market, in the OEM market? I'm guessing that not many new companies in this field, they would have robotic engineers at the ready. What would your advice to them be?
I'm going through that very same question. So do I employ outside engineering on robotics? Do I work with a company who's already involved in that? And so in most aspects, I'm going to say, I'm going to outsource that until I get so much of it that I have to employ an in-house personnel. Right now, I'm on the outsourcing model when it comes to automation robotics. So,
Is it easy enough to find qualified people to outsource to?
It is. It can be a challenge making sure that they mesh with your core and company values and your design characteristic. But there are companies that are out there. They're available. They're hungry to grow their market right now. And they know that food production will continue to automate.
Okay. Nate Harrison, thank you so much for joining us today. This is all we have time for. It's been a real pleasure. And to all you listeners out there, if you have any questions whatsoever or topics or maybe people that we need to interview, do reach out to us on podcast@ngi-global.com. And that was podcast@ngi-global.com. It's a real tongue twister. Now, if you enjoyed this episode, please hit the subscribe button and of course share it with your friends or your colleagues or even your family if you feel like it. And I think, with that, thank you so much for listening.
Thank you very much for having me. I really appreciate it.